and today we're going to learn about imaginary numbers. They exist, kind of. So the imaginary numbers set deals with the imaginary unit I. That's supposed to be an I. And I, the imaginary unit, is equal to the square root of -1. So imaginary numbers come from taking the square root of negative numbers, which we haven't been able to do yet. But after today, we will be able to do that, at least algebraically. So, where do these come from and what do these look like? It's a great question. Let's get right to it. So imaginary numbers come from, one of the places they come from is taking the square roots of negative numbers. I'm going to put this up in the upper corner because this is going to be important for every single example we're going to do. Understanding that the imaginary unit I is equal to the square root of -1. Another important thing we need to know is that if you have a number inside a square root that is two different numbers being multiplied together, you can actually split these up into their own radicals and multiply them together. Just to give you a really quick example of that, something like the square root of 15, you can break that up into the square root of 5 multiplied by the square root of 3. Okay, so 15 is 5 times 3, and then you break up the 5 and 3 separately. Okay, we're going to need both of those pieces of information in order to do what we're going to do for the following examples. So let's start off with this. What is the square root of -9? So again, we get an error message if we put this into our calculator. But if we're allowed to use imaginary numbers, we can actually find an imaginary value for this. The way that we do that is we are going to separate the negative part from the non-negative part. So I'm going to take -1, put it under its own radical, and then 9, put it under its own radical. And notice if you do multiply -1 and 9, you get -9. So I'm kind of using this rule right here. Now what we're going to do is we're going to substitute. So square root of -1 by definition is I, so this turns into an I times square root of 9. 9 is a perfect square. When you take the square root of it, you end up getting 3. So this is I times 3. Now normally when we have a variable, this isn't a variable, but still usually letter representation and numeric representation, the numeric comes first. So we would actually see this written like this, right? The square root of -9 is equal to 3I. So this is actually the value of the square root of -9 in imaginary number world. All right, we're going to do a couple. We're going to do another one. This time we're going to take the square root of -25. Okay, so the square root of -25. We're going to start off very similarly. We're going to separate the negative from the positive. So we're going to have -1 under its own radical and then 25 under its own radical. Notice again, if you multiply these together, you get -25, which means this property right here is good. Square root of -1 is I. Square root of 25 is 5. I times 5, but again, we usually rearrange it so that the number is first. So there is our answer. The square root of -25 is equal to 5I. It's an imaginary number, so it's not something that's going to appear on a calculator unless your calculator is set to accept imaginary numbers. Okay. For the next example, we're going to do something interesting. We're going to take a number that isn't a perfect square anyways and make it negative. So what's the square root of -6? We're going to still start off the same way. We're going to separate the negative part from the positive part. So again, 6 times -1 is -6. We're good. This turns into an I. This isn't a perfect square. And there's nothing you can divide 6 by that is a perfect square. So it just stays root 6. And this is as far as we can go with this. The square root of -6 is I root 6. All we really can do is take that negative component out and call it an I. And that's it. This would be as far as we can go. There's our solution, or there's our answer at least. Square root of -6 is I root 6. Okay? Now we're going to do one of the trickiest versions. We're going to look at something like the square root of -18. Okay? Once again, we want to separate the negative part from the positive part. So there we go. But though 18 isn't a perfect square, there is a number you can divide 18 by that is a perfect square. In other words, we can take 18 and we can split it into two numbers where one of them is a perfect square. One of them won't be. What two numbers multiply to give you 18 where one of them is a perfect square? That should be a 9 and a 2. 2 times 9 is 18, and 9 is a perfect square. So what happens is this turns into an I by definition. This you can take the square root of. Square root of 9 is 3. This you can't take the square root of, so it just stays root 2. And we just rearrange these in the order that is, I guess, was set forth. So the order that was set forth by the math gods would be that the number, the coefficient, comes first, the letter representations come second, and then square roots come last. So your answer to what is the square root of negative 18 would be 3i root 2. 3 times I times root 2, where I is the imaginary unit. It's an imaginary number, but it is the value. Okay? We're going to do one more. Do something like the square root of negative 75. This would be a nice one. Okay? Once again, we're going to take out that negative part and 75 here. But 75 has a number that goes evenly into it that is a perfect square. Can you think of two numbers that multiply to 75, but one of them is a perfect square? So you're basically trying to break up 75 into two numbers that multiply. And again, that is supposed to be 75. Just do this real quick. There we go. 25. It's 25 times 3. Okay, again, 3 times 25 is 75. 75 times negative 1 is negative 75. When you multiply all these together, you should end up getting what's on the inside here, right? That's your check. Okay. Square root of negative 1 is I times square root of 25 is 5 times, we can't break up the square root of 3 any further, so it just stays like that. So we have 5i root 3. Oop, didn't want to do that. See if I can undo that. No, I cannot undo that. Well, you get the idea. You know what the answer is supposed to be. Go away. So your answer is 5i root 3. Okay, that's it.